Hi there, Nikki here, and welcome to another network automation video. So in this video I'm going to demonstrate automated testing using the Ansible Assert module. This video will build on my previous video where I deployed BGP and OSPF on my Eve NG lab, and now I'm going to verify that all the BGP pairings have come up, all the OSPF pairings have come up, and then at the end I'm going to run some ping tests between the two branch sites to make sure that the connectivity via the core site has been successfully deployed. So if we just have a look at the lab, as a reminder, the core site is two routers. I have two branch sites and I run BGP between all of the routers. So each router will have a connection to both core sites on point-to-point links running a /30 subnet, and the design is that the core site always has the lower IP in the subnet. So if this EAT0/1 is a .2 address, then the core will be .1, etc. We also have OSPF down to the switch in each branch on the Ethernet 0/0 of both routers. So each router will have one OSPF pair, and then the switch has deployed three VLANs, VLAN 10, 20 and 30, and we will run some ping tests between those VLANs to verify the connectivity through the core. So I've just also included a couple of errors into the network that's going to cause some failures as well, so we can see the difference between when a test passes and fails. So what I've done is I've shut down the E0/1 interface on this router, so it will only have one BGP session, and I've also shut down one of the VLANs on this switch. So we'll see when we step through the tests that we'll get a warning message about that and instructing us to seek to rectify it. So if we have a look at the directory on the Ansible host, again I'm using fact caching so that I don't need to run the gather facts or iOS facts every time that I run a playbook, so it speeds it up. So I just run this simple playbook which stores the facts for each of the routers and switches in this directory. And if we look at one of these files, we will see that the information is stored in JSON format. So if I just look at this one here, so we've got dictionaries of lists and lists with dictionaries, etc. But what we were interested in this video is the Ansible_net interface, and in particular Ethernet 0/1. So if we connect into a branch router and we want to verify the BGP pairing on 0/1, we can find out through facts what the IP address of the interface is, and we know because of the design that if this IP address is 10.2.0.2, then the core must be 10.2.0.1, and we can do a simple IP math function to determine what the BGP pairing address is, which saves us for having to connect into the other router to work out what the IP address is. So with that, if we just continue on with what we have in here, we've got our host file as before, and the host file has got its groupings. The groupings that we're interested in this video is the CE. So we will, when we verify BGP and OSPF pairings, we will use the CE grouping because we can verify all those pairings on these four routers. And when we do the ping tests, we'll do that for the switches, so we'll use this grouping. We'll also, in reporting, in our messages, we will call out the host name of the device, and the host name here is referred to a reserved variable called inventory_hostname. So that will be also in our playbook. So I've split the tests into numerous plays, so it's easier to manage and easier to see the output that we're going to produce, because there'll be quite a lot of output. So if we just start off with verifying BGP and have a look what we're trying to do here. So we've got a number of tasks here in this play that we're going to run against our CE devices, our 4 branch devices. So what we're going to do is, for each device, we're going to have 2 tasks to verify the BGP pairing to site 1 router 1, and then it's very similar tasks to do the exact same thing for site 1 router 2. And if we have a look at the first module, the iOS command module, the command that we're running is show IP BGP neighbor IP address pipe IP math -1. So we grab the IP address of our Ethernet 0/1 and we pass that IP into the IP math function, and we subtract 1, and the result is the IP address of our BGP pair. And then in the output we include BGP state. So if we just quickly connect into router 1 to see what that will look like, if we do show IP BGP summary to see what pairs we have, we can see that we have the .1 and the .5, and as expected one of them is in an idle state, so it's down, and one of them is established. So if we do a show IP BGP neighbor on our established one, which is 10.2.0.5, we can see that in the output of the show IP BGP neighbor command, one line gives us the information we're looking at: BGP state equals established. So if we were to filter that to just BGP state, we get one line of output, and then when we want to query that, we will look for the word established. If we find that, we know the BGP pairing is up. If we don't find it, then the opposite, obviously the BGP pairing is down. So if we were to look at the other BGP pair, we can see that the state is idle, and that's what our tests are going to look to determine. So if we go back to the Ansible hosts, we can see that we run the show IP BGP neighbor command, and using the register model we save the output into a variable called result. Then we use the assert module to verify that result. So the Ansible Assert module is used to check a condition if something exists or not exists, and it will report a failure or a success. In our instance here, we're asserting that the word established appears in the result .standardout0. If this condition is met, we will display the success message saying BGP pair between this router that we're currently automating and router S1-R1 is up. Otherwise, we'll display a failure message requesting a verification of the pairing, which will instruct the engineer to log into the router and work out why that pairing is not up. And then we repeat it for the Ethernet 0/2 pairing up to router 2 in site 1, the exact same steps. So let's run this playbook. So Ansible verify BGP. So it captures the output of our show IP BGP neighbor command. So successfully run the show IP BGP neighbor command, and now it's running the asserts. So we can see that we have our failure here on site 2 router 1 as expected, seeing that the pairing between this router and router site 1 router 1 is down, and please verify, and the other pairings are all up. Then we move on to the second 2 tasks, where it runs the same command again, but this time looking for site 2 router 2. And if you look at the output closely, you will see that in the first task we ran it 4 times for site 2 router 1 and 2 and site 3 router 1 and 2. But in the second task we only ran it 3 times, because site 2 router 1 is not run the second time round. And the reason for that is because the assert failed. So the way that the assert module works by default is if it reaches a failure for a particular host, it stops the play at that point and doesn't run any further tasks. So that would be useful if you had one task that should only run if another task was successful. So you could run the first task and then straight afterwards run an assert to verify that task and only permit the second task to run if the assert is successful. In our case here, it doesn't matter if that first task fails. We still want to verify is the BGP pair up to the other router. So that is configurable. So if we go back into our play and we add the following, which is ignore errors, and set that to yes, then it should we should then the second time round get 4 results on our second tasks. So we run it again. So this time we get our failure again, but we have this addition, ... ignoring. So that is that ignore errors yes, and that means that on the second run when we're verifying the BGP connection up to site 1 router 2, it's going to run for site 2 router 1 as well. So we run our show IP BGP including site 2 router 1, and we run our asserts, and we should, if they're all successful, get 4 passes as we do. So this time we have a more complete result. So we could then go on to site 2 router 1 and enable that interface. And once we do that, we should see the BGP pairing come straight up, hopefully. Yep, there we go. So now we know that all our BGP pairings are successfully set up. So we can move on to verifying our OSPF. So if we look at our OSPF YAML file, this time again disable gather facts, running them off the branch routers, which is the CE grouping. We're going to run the iOS command show IP OSPF neighbor and register the output of that command to the variable result as before. And in our assert this time, we're going to assert that either one of 2 addresses appear in the result. So we're using the site ID, which is in the host file. So site 2, its IPs are 10.2 and site 3 is 10.3. So with that variable, we say if 10.2.0.254, which is the OSPF pair from router 1 to the switch, or 10.2.0.250, which is router 2 to the switch, is in the output, we'll deem this a success. So this works because the switches only have one OSPF pairing, so it's going to be either or these IP addresses. So this condition will cover both routers. So if we run this now, verify OSPF. So it's run now, and we've got a success message on all of our routers. So our OSPF is up on all 4 routers. And finally, what we want to do is run some connectivity tests. So we won't be using the assert module this time, we'll just be pinging. But just to show you what we have here, we've got 3 VLANs on both sides. Show IP in brief. So we've VLAN 10, 20 and 30. And on site 2 switch 1, I've shut down VLAN 20. On the other side, all 3 VLANs are up. So we're going to get a failure on this one, but the others should work. So what we need to do in this instance is I want to, when I connect into this switch, I want to ping these 3 IPs from this switch. This will tell me if this switch has an interface down, such as this one, and then ping the 3 IPs of the other switch. So we're pinging on both switches 6 IPs. So we need to either have a long list of tasks to ping each IP individually, or have some mechanism to loop the IPs. So what I've done in this instance is I've stored the IPs in a YAML file in a list. So I've got a YAML file called branch_VLANs, and that YAML file is a list with all our 6 IPs. So this list name branch_VLANs here inside the file becomes the variable that we will use inside the play, and we will loop through that variable and run our ping against each of these IPs. So this is a bit more complex than the other one. So if we have a look at what I mean, this is what we're doing here. We're running against the switches. Our first task is going to load the branch VLAN IPs that I have in the dedicated YAML file using the include_vars module, and then you point the branch VLANs.yaml to the file option, and then we're going to loop. So we're going to run the iOS command, and in the commands we're going to run a ping and include a loop of that list branch_VLANs. What that means is that for each IP, it's going to pass the IP which is referred to by the variable name item by default when you loop, and run the ping. And we're sourcing our pings off VLAN 10. So this will run 6 pings on each device, and then we register the result of the pings into a variable called result. And using the debug module, I am going to display the contents of the result variable, and I can show you how it looks different when you use the loop to when we normally use it. And then I will get onto this assert module here when I run this. So if I run this so I did say I'm not going to use the assert module on ping, but of course I am. I'm gonna run the ping, and then I'm going to assert that the output of the ping tells me that it was a successful ping. But if we just run this play first, you will see, first of all, the task runs and it's looping through each of the devices, and you will see that this one task caters for all 6 of the pings. So when we see an OK here, it's not telling us that the ping is OK, it's just telling us that the ping command is run successfully, whether it got 5 successful responses or no successful responses. And then we run the debug command, and I just wanted to illustrate why this is a bit trickier than what we previously done. So previously, when we saved the output of a command with the register command to a result, what we get is a construct that has a list with one element, and that is element 0. So we would go result.standardout0. But in this instance, you will see that we have a separate element for each ping. So when we look at this site 2 switch 1, we have a result variable, and inside of that we have a results dictionary, and then inside the dictionary we have a list of numerous dictionaries, and each element of the list is a different IP address. So we've got item 10 to 10.1, one of the IPs we're pinging, and standard out is another list with a single element, standard out lines, and it repeats for each of the pings. So it's a much longer, more complicated construct. So if we go back in to our play, we will see that in order to interrogate this particular output, we have to refer to the variable result, and inside that results element 0 or 1 or 2 or 3 or whatever, and then in that standard out 0. So this will refer to just one of those IPs. So if we wanted to run an assert checking that the ping was successful via the usual Cisco iOS response codes for pings, we would have to have a separate assert module for each result. So we'd have results 0, result 1, result 2, etc. And we'd have a long list of assert modules. However, the problem that we have here is that we have two tasks. We have a task to run the ping and a task for the assert. And unfortunately with loops, you can't have more than one task in a loop. You must separate your tasks into a separate file and then use the include tasks module to include that in your loop. And I'll just show you how we do that. So that's just a limitation of the loops module, and just ignore that. And the other thing as well with the loops is that Ansible loops repeat a single task. So if you remember, when the first time that we ran this and we looped over our pings, we had one task and it just ran the ping 6 times in our output. If I just go back here. So you can see there's a lot of output there. But when we ran our loop with our single task, it's just Ansible just treats that as one task and runs the ping for each device, the 6 pings. But when we use Ansible loops, it will repeat a single task. So when we do it this way, we're going to get a lot more tasks in the output. So I'll just demonstrate how we do that. So what I've done firstly is I've taken I've simplified the first play here. So what I've done is I've taken out my iOS command module and my assert module, put that into a separate YAML file, and I include it. So I still use my include vars to bring in my IP addresses, but then in my second task I'm using the include tasks and I'm referring to that branch, to the branch ping.yaml file, and then I run a loop over my VLANs. So for each, what this means for each IP, I'm going to run the tasks in this file here. And just to demonstrate that you can actually control the name of that variable item and give it a more meaningful name, I just added that into my loop control with the loop var. So instead of saying item, I'm saying test underscore IP, which is more meaningful, and I'll be able to use that in the branch underscore ping.yaml file. So if I just look at that, so branch underscore ping. So now in here, I've the two tasks as before. iOS command, I'm pinging my destination IP from source VLAN 10, register that to result. Because this now becomes a single task, I don't have that convoluted result.results square brackets 1 dot standard out square bracket 0. It's just how we were using it previously. It's simply result.standard out 0. So I assert that the exclamation marks appear in the result, and then I have a fail message and a successful message. And I also need to include ignore errors here, yes, so that will go on to the next task and the next task for the other IPs. So if we run this now and see what result we get. So it's verify we are pinged, and I should just include my host file, so minus I hosts. So we load the branch VLAN IPs and we start pinging the branches. So first it's the include task, so it includes it for each IP, so we get it 6 times, and that's the iOS command and assert, and now we start pinging. So you will see that this time when we ping, we're running a separate task for each IP on the 2 switches. So we're going to get a lot more tasks this time. So we go through the 10.2.10.1, and we can see that we have a failure on switch in site 2, the VLAN 20 as expected, and it's ignoring the failure, allowing the other IPs to also be verified. And then it goes through the 10.3, .10.1, .20.1. They all work, and we record down here that in red that we had some failures. So we can see that there's something wrong with 10.2.20, so we can go in and verify that. So we just simply, in this case, go in and enable that SVI. So int VLAN 20 no shut, and that should mean that the next time we run this, all our tests should pass. So if we just run it again just to verify, and then that will be all our tests. So this time they will all pass, and that will conclude the video on automated testing. I think automated testing is just as important as the deployment tasks that we configure with Ansible, because if you're automating a large network of say hundreds of routers, and you deploy some configuration, you want to know that that deployment was successful and it didn't fail somewhere. I've noticed with Ansible sometimes funny things can happen, and it can miss a router for whatever reason, whether it's a CPU spike on the host itself or something going on the router. But if you've automated testing and you get that feedback, you're verifying the work that you have asked of your deployment playbooks has been successful. So I always include it. I think it's really important. And now we can see this time we're going to get a clean output. One more test, and our summary should hopefully say that we have no error messages, and we have 19 OKs for both switches. And you can see that the number is much higher, as I said, because with the loops it runs a single task multiple times, so the output is a lot more, so watch out for that. So that concludes my automated testing video. I hope that will have been some help to you. Thank you.